No, he didn't. I have a whole slew of them in second period, so a whole group of them.
So you don't know shit?
I mean, I know, but I'm not gonna like call them out.
Wait, what did you do?
All right, here we go. Yesterday we talked about division that we did in middle and elementary school. Okay. Today we are moving on to polynomial division. So please pay attention today, okay? Because if you, I really want you to get this. It's not difficult, it's just tedious, okay? So I'm going to be using a pencil and a red pen, all right? The very first thing that I always want to do, I want to check and make sure I have all my powers. My highest power is 2, so my powers go 2, 1, 0. I am not missing anything. That is good, okay? So I am going to divide x plus 2. I'm dividing 3x squared plus 7x plus 2 by x plus 2. All right? Now, I want you guys to remember kind of this process of how we were getting the numbers that we were subtracting and all that other stuff. So I'm going to refer back to this a little bit. All right? But when I'm doing polynomial division, okay, I need to focus in on this very first variable up front. All right? So my question is also, when I'm doing division, I need to be thinking about multiplication at all times, all right? What would I multiply by x to give me exactly 3x squared? 3x. Okay. So I'm going to put a 3x up here on the top. Now, how did I get the 10 that I had underneath that 14? You multiplied, right? So I'm going to multiply here also. I'm going to multiply the 3x not only by the x to get the 3x squared, but I've got to multiply it by the 2 also. So 3x times 2 is 6x. Okay? Then I came through and I subtracted. So yesterday I did 5 times 2 and I got 10. Here I did 3x times x and 3x times 2. It's like the distributive property, okay? Then I come through and subtract. You've got to subtract every single term, all right? So when I come through and I subtract those, the 3x squareds cancel out. 7x minus 6x is 1x. And then y'all remember how I brought the 6 down yesterday? I'm going to bring down the plus 2. Now, I don't care about this original dividend, okay? I'm now looking here on this new level. What do I multiply by x to give me x? 1. If I multiply by x, that's going to give me x squared. Okay, so right here, I've got to do 1 times x and 1 times 2. Well, 1 times x is x, and 1 times 2 is positive 2. And when I come through and subtract, what happens? Both of them cancel out, and I'm left with a 0 remainder. That's it. So technically, this 3x plus 1 right here, that's my quotient. That's my answer. Okay? But I want to show you that because it divided and gave me a 0 remainder, I can say that 3x squared plus 7x plus 2, my original dividend, is equal to the product of x plus 2 times 3x plus 1. So that factored pretty. Okay? So I'm going to say that this right here is the factorization of that original polynomial. If I were to factor it, that says factorization. Okay, sorry for those who are in the back. Okay, now that only happened, this factorization only happened because I had a zero remainder. This means that it divides evenly into that. Okay, we like zero remainders. Yeah, my quotient is 3x plus 1. Okay. All right. Take a look at this one. First of all, I'm looking around, and the highest power that I've got is 3. Y'all pick your heads up, please. Okay. The highest power I've got is 3. But it's definitely not in standard form. So I'm going to rewrite this. I've got x to the third plus 3x squared. What's missing? I don't have an x term, right? I don't have an x to the first power. Technically I do. Its coefficient is just 0. Okay? And then I will have minus 4. Do you see now how my powers walk down? 3, 2, 1, 0. If I am missing something, okay? If I am missing something, you have to put a 0 in its place.
So what are we missing? The 1.
We were missing an x to the first power. All I have done is take this dividend and I have written it in descending order. I put it in standard form, but I also wrote in what was missing. Okay? So this is what I am dividing by x minus 1. I just had to rewrite it. Now, this is where I take that divisor and I write it underneath my division bar. You have to put those placeholders in there. Okay? And this is where I only really want to pay attention to this x out front. Okay? My goal is to get x cubed. What would I multiply by x to give me x cubed? X squared. X to the second power. Okay? Now, this x squared gets multiplied by both of these terms. X squared times x, x squared times negative 1. That gives me x cubed minus x squared. Now, I'm going to subtract, but when I subtract a negative, it changes my signs, y'all. So this negative x squared becomes a plus x squared. Here we go. X cubes cancel out. What is 3x squared plus x squared? 4x squared. Then I'm going to bring everything else down. I want to keep everything on one level. My question now is, what do I multiply by x to give me 4x squared? 4x. So 4x times x and 4x times negative 1. That gives me 4x squared and negative 4x. So we come through and subtract. We're going to subtract the 4x squared, and I end up adding the 4x because it was a minus. And when I subtract a negative, that double negative becomes positive. What is 0 plus 4? 4. So that's 4x minus 4. What would I multiply by x to give me 4x? Just 4. So 4 times x and 4 times negative 1. That's 4x minus 4. And y'all, what happens when I come through and subtract? Everything cancels out, and once again I've got a 0 remainder, which I love because that means I have a pretty quotient. If it is not a pretty quotient, or if I have a remainder, then I have something ugly. Okay? All right, let's look up at the top of page 10. Now this one is written, this still means division. It's just written as a fraction to begin with, okay? Now, right here, my highest power is 6, okay? I know that I'm dividing x plus 1 into this polynomial. Now, this is x to the 6, so it's going to be a long polynomial in here, okay? I've got x to the 6th plus 4x to the 5th. What am I missing? An x to the 4th, right? So I got to put plus 0x to the 4th minus 2x cubed plus 0x squared plus 0x plus 7.
So it's
Y'all,
so if you have 6 and 3, you have
you have to have every variable, okay? This is x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. You have to have every single one, okay? If there is not one there, you write it in with a 0 coefficient. Okay, now I'm going to put a box around this x because that's what I'm really looking at. Okay, what do I multiply by x to give me x to the 6th? X to the 5th. Okay, so this x to the 5th gets multiplied by the x and the 1. So that's x to the 6th plus x to the 5th.
and then bring everything.
Then we subtract. The x to the 6th cancels. What is 4 minus 1? 3. So that's 3x to the 5th. And I'm bringing everything down.
How do you know when you bring everything down?
After you subtract. We're going to keep bringing it down until we're done. Okay? Do you see how I just lost a term? We got to get to where we don't have any more. It's just a process. Yep. One after the other. I told you it's just tedious. Okay? It's not that it's difficult. It's that it's tedious. Okay? What do I multiply by x to give me 3x to the 5th? 3x to the 4th. Okay? So 3x to the 4th times x and 3x to the 4th times 1. That gives me 3x to the 5th plus 3x to the 4th. I'm going to come through and subtract. The x to the 5ths go away. But what is 0 minus 3? Negative 3. So negative 3x to the fourth.
Bring it down.
And bring it down.
Wait, I'm understanding. It's clicking.
Good. Hey, the only way to learn math is to do math. The only way to get better at reading is to read, okay? I see a lot of people rolling their eyes or like throwing their eyes in the back of their head like, oh my God, what is happening? Breathe. Meditate for a second if you need to. But I will also say this. When you are not here, you don't learn. Make sure you are here. Not just physically, friends. Not just physically. That's not what I'm talking about. I'm talking about your brain power too, okay? All right, now, I brought everything down. I now care about this. What do I multiply by x to give me negative 3x to the fourth? Negative 3x to the third. Perfect. Now, negative 3x to the third times x is negative 3x to the fourth. Negative 3x to the third times 1 is still just negative 3x to the third. All right. So then we subtract. But y'all look. All these are negative, right? So if I subtract a negative, it turns it positive. Well, the x to the fourths do. You're right. Okay? But what is negative 2 plus 3? 1. Just x to the third. Bring it down. Oh my goodness. Y'all act like y'all's whining that this is too much. It's going to change what we got to do. I would much rather you have this in your notes for your practices. Nope. Well, yeah, you always are subtracting. Okay? That is your process. Hey, I just had a really good question. She said, so you're always subtracting? Yes. Do you remember how yesterday we did that, just the number division? And I would come through and I would subtract every time. Okay? Remember, division is repeated subtraction. Okay? Division is repeated subtraction. All right. Now I care about the x to the third. What do I multiply by x to get x to the third?
X to the second.
X to the second. So x squared times x is x to the third. X squared times 1 is x to the second. And I come through and subtract. Now both of those were positive, so they just turn negative. Yeah, me too. The x cubes are going away. Huh? Well, so right here, yes, I have that 0. But what is 0 minus 1? Negative 1, so negative x squared. Hey, guess what? Why? No. Whining isn't going to change anything, friends. Okay? We're not done yet. Because I can still look right here. Can I multiply x by something to get negative x squared? Negative x. So negative x times x is negative x squared. And because it's a high-powered function, why is it so long? Okay. Negative x times 1 is negative x. I'm just repeating kind of what I'm hearing in my brain. Oh my gosh, why is it so long? This is so much. It's just a lot of steps. All right, now I'm coming through and I'm subtracting. So what happens when I subtract negatives? They both turn positive. So the x squareds cancel. I have 1x plus 7. Okay? What do you multiply by x to get x? 1. So plus 1. 1 times x is x, and 1 times 1 is 1. When I come through and subtract, the x's cancel. What? But I just subtracted. I went through and subtracted. So 6.
And so what do we do?
Okay, now, if I have a remainder. No. If y'all will be quiet, I will tell you. All right, I am going to take my remainder, which is positive 6, and I am going to put it up here with my quotient. I'm going to put plus 6, but I have to create a fraction. 6 over x plus 1. No, not 6, 7. Okay? No, not 6, 7. Okay? My quotient is this big, ugly, long polynomial with the remainder stuck in the back. It is special. Thank you, DJ. DJ just made my heart happy. Now, as much as you guys, my second period, full of people who like to normally whine and complain, they didn't say a word. But I will say, I do like that you're engaged. Okay? However, I don't want to leave you with one worked out like that and just expect that you know how to do it. No, check back in. Okay? Let's look at this one. Okay, now look. All I have is an x to the 4th and a 9. Okay, I'm going to do my x plus 3 on the outside. Okay, now this one's not going to be as long because it's not as high of a power, okay? I have x to the 4th plus 0x cubed plus 0x squared plus 0x plus 9.
The first step is to
Hold on.
figure out how to
I want to look at this x. This is my reference point, okay? What do I multiply by x to give me x to the 4th?
It's the third.
X to the 3rd. Now, this x to the 3rd gets multiplied by the x and the 3. It's like the distributive property, okay? So this is x to the 3rd power plus 3x to the 3rd. And what do I come through and do? Okay. So I am subtracting. Oh, that should be x to the 4th. I'm sorry. Okay. My x to the 4ths cancel out. Then I've got 0x cubed minus 3x cubed. So that's just negative 3x cubed. And we bring it down. What do I multiply by x to give me negative 3x cubed? Negative 3x to the 2nd power. Okay, Negative 3x squared gets multiplied by the x and the 3. So this is negative 3x cubed minus 9x squared. Negative 3 times positive 3. You're okay. Yes, so when I come through and subtract, that changes both of those negatives to positives. So the x cubes cancel.
And it's like 9x is...
Yep, nope,
It's
nope.
not negative
Because remember, I changed the sign. So that is positive 9x squared. And then we bring it down. Okay? What's my next term going to be right here? 9x. Excellent. 9x times x and 9x times 3. Okay? That's going to give me 9x squared plus 27x. 27. Okay? I'm coming through and I'm subtracting. Yep, that's going to be a negative 27x plus 9 because we bring it down. We're almost done. We're almost done. Okay, now right here, what do I multiply by x to give me negative 27x? Negative 27. So that's negative 27x. And then that actually gives me negative 81. When you come through and you subtract, it changes your signs. So this ends up being 90. So 90 is my remainder because I can't multiply x by anything that's going to give me 90, right?
Yeah.
Okay. Yes. Good job. That is going to be plus 90 over x plus 3. You put it over your divisor. Yes. Always subtracting. Okay. Now that I've taught you the ugly way, because long division has its purpose, okay? Long division has its purpose. Let's look at synthetic division, which is a shortcut / fake division. You are exactly right, okay? Now, this only works, though, if your divisor is in the form, it's a first degree polynomial, so it's something like x plus 3, or x plus 1, or x plus 2, okay? Now, let me show you this, and then I'll come back up here, okay? So let's go ahead and let's look at this. The very first thing that I need to do is I need to take my divisor. I'm going to take my divisor, which here is x plus 1, and I'm going to set it equal to 0, and I'm going to solve for x. So I move that plus 1 over, and x equals negative 1. Okay? I am going to use that number, and I'm going to create like an upside down division box. And that number goes on the outside of that division box. Okay? Now, I'm checking my powers. I have 3, 2, 1, 0. Am I missing anything? No. So what I'm going to do right here, okay? I'm going to use my coefficients. So I have 1, negative 4, 2, and negative 1. And I'm going to write those coefficients on the inside of my upside down division bar. Don't need as much space. Okay? And underneath the last one, right here, I am going to create what I call my remainder box. Okay? All right, so here is my process. Pay attention very closely, okay? I am going to always bring that very first one straight down. Put your phone away. I turned in phones to the office yesterday, and I'm happy to continue. Nobody in my class has a 100, so nobody is going to have their phone. Now, on the outside, I am going to take this number and I'm going to multiply it by this number. So -1 times +1 is -1. I am going to write that product inside in the next open spot. Okay? Then on the inside, okay, on the inside, I'm going to take those numbers and I am going to add them up to get my new number on the outside. -1 times 1 gave me -1, but -4 minus 1 more is -5. I'm adding them together. So next, you're going to multiply -1 times -5, which is +5. And then we're going to add those numbers together and we get 7. Then I do -1 times 7 and I get -7. And then we add one last time and I get -8. Okay? Now, this right here, this gives me the coefficients of my divided polynomial. Okay? It's the coefficients of my quotient. This right here is my remainder box. So -8 is my remainder. This 7 is going to be my constant. The -5 is my x to the first power term, and my 1 will be x to the second power. So do you see how my powers go 2, 1, 0 remainder? Okay? So what I do here, I take the coefficient and I write each term. This is 1x squared minus 5x plus 7. My remainder here was -8, so I'm going to create a fraction. I've got -8 for -8, and then we will go back up and put our divisor, which was x plus 1, as my final answer. So this is the quotient. Okay? Now I have another example worked out for you, showing you the steps right here. Multiply. Move your number here and you add them. Multiply. Put your number here, add them. Multiply. Put your number here, add them. Okay? And this is marked with your remainder, and you can see the quotient. Okay? But I do want to mark right here that this is the very first thing that you work with. Okay? That has to be the first thing that you do. Okay? All right, if I'm looking at this polynomial, This is written in fraction form, and that's fine, okay? I'm going to start with the x plus 2, which is my divisor. I set it equal to 0, and I solve for x. That gives me negative 2. So that means on the outside of my box, I've got to have a negative 2. This is where I go get my coefficients, but I'm also paying attention to my powers that I do or do not have. I'm starting out with 1x to the 4th. Do I have an x cubed? So you got to put a 0 next. Then I have negative 7x squared minus 6x, and then what am I missing? Your constant. So you got to put a 0 in the constant's place. Okay? That is your constant, and you were missing that, so you have to put a 0. This was 4, 3, 2, 1, 0. I'm good. I'm going to drop the first one to the outside. This is what gives me the start of my process. Now, what do I do on the outside? Multiply. Negative 2 times positive 1 is negative 2. And then I add those numbers together, so that gives me negative 2. Negative 2 times negative 2 is positive 4. And negative 7 plus 4 is negative 3. What's negative 2 times negative 3? Positive 6. What's negative 6 plus 6? 0. Negative 2 times 0 is 0. And then once again, I have a 0 remainder. I like when I get a 0 remainder. Okay? I like when that happens. Now, I'm going to come through right here. Remainder, constant, x to the first, x to the second, x to the third. You're walking your powers up as you move from right to left. We're going backwards, right? Okay. So my quotient here is 1x cubed minus 2x squared minus 3x, and then I've got zeros. Do I need to write those for my quotient? No. Done. Okay? Okay. Flip it over. All right, I want to look down here at these bottom two. Do you see how these are just a little bit different? Do you see your divisor? You've got something other than just an x plus or minus. Here you've got a coefficient. So right here, if I take this 2x minus 3 and I set it equal to 0, if I'm solving for x, the very first thing that I'm going to do is add 3 to both sides. So then I get that x is 3/2. Okay? So on the outside, I know that this is a fraction, but thankfully it's a fraction that has a denominator of 2. Okay? Now I want to put my coefficients in. The highest power that I see is x to the 5th. Okay, so I'm going to put its coefficient of 4. Then I had negative 3x to the 4th. Do I have an x cubed? Yep. What happened to the what? Right here? I just divided both sides by 2. Yeah, I would leave it a fraction. Okay? You see what I'm... Okay. All right, do I have an x to the 3rd power? No. So you gotta put a 0 in its place as a placeholder. Then I have positive 6x squared, negative 1x, and then my constant was 9. And underneath the 9, I'm going to put my remainder box. Okay? All right. Here we go. I'm going to drop the 4 right here. And then I'm going to do 3 halves times 4. But this is just 3 times 4, which is 12. And 12 divided by 2 is 6. Okay? So right here, that's going to give me 3. Okay? Well, 3 times 3 halves. Unfortunately, that's going to give me a fraction of 9 halves. But when I add that, I still get 9 halves. Fractions are not wrong, friends. Okay? Now, I do want to show you, when I do a fraction in the calculator, I can do alpha y equals, and I'm going to do 3 over 2, and I'm going to multiply that by 9 over 2. And that gives me 27 fourths. Okay? And I'm adding 27 fourths and 6. That gives me 51 fourths. If you don't like the fractions, you can absolutely turn them to decimals, but I'm trying to leave everything alone for right now. Or would you prefer that I change it to a decimal? Fraction? Okay. All right, here we go. Now, I'm going to multiply that times the 3 halves. I get 153 over 4. And I'm subtracting 1 from that. So that's 145 over 4. Once again, I'm multiplying. Huh?
It says over 8 on the calculator.
Over 8. You're right. Thank you. Good catch. Oh my goodness. Good catch. My eyes clearly don't work that well. Okay? It's 145 over 8. I just wrote down a 4. Okay? Now I'm going to multiply that by 3 over 2. That gives me 435 over 16. And I'm going to add 9. And that is the ugly fraction, 579 over 16. Now, there is one final step in the end. Okay? Whatever my denominator was, you need to come through and divide every single one of these by 2. Okay? The first 2 are easy. 4 divided by 2 is just 4. I'm sorry, 2. God bless. It's 2. Then 3 divided by 2. Are y'all okay if I just leave that alone? Okay? Then I have 9 over 2, and I am dividing that fraction by 2. That gives me 9 over 4. Then I have 51 over, oh my goodness, come on now. 51 over 4 divided by 2. That gives me 51 over 8. The next one, you can kind of see what's happening to the denominators. Okay, that will give me 145 over 16. And this will give me 579 over 32. Now, I know this is not pretty. Okay, I understand that. This is still my remainder. This is my constant, x squared, x cubed, and x to the 4th. Now this should make sense because I was taking an x to the 5th and dividing out 1x. So that should leave me with an x to the 4th. Okay? So my quotient here is 2x to the 4th plus 3 halves x cubed, and then plus all the rest of it. Okay? Now, I don't like the ones that have these little fraction situations happening. Okay? I like the other synthetic division ones a lot better. However, don't you agree that this is still a lot better, okay, than what I had? So I'm going to write this as 579 over 16, but then I'm still going to put that over 2x minus 3. Aren't you glad we didn't have to do that one by long division? Okay? All right, you should at least have homework 10 done before you come back on Monday. I 0 out of 10 recommend taking next Friday's quiz without having practiced this stuff. Hey. Huh? Okay.